Hello everyone. Call tool result patterns. Every tool response in MCP travels inside a call tool result envelope. Previous sections return plain Python values and it let FastMCP wrap them automatically. This section goes one level deeper. The server returns call tool result directly, giving explicit control over the content list, error flags, embedded resources, images, and metadata. Part 1. The server. Call tool result is the protocol level return envelope. Text content, image content, and embedded resource are the three content item types that go inside it. FastMCP's image is a server-side convenience that FastMCP converts to image content on the wire. Annotated attaches a pedantic model to a call tool result return type, so FastMCP can validate structured content against it. We start by creating the server. This one line, one instance. All tools registered below belongs to this server. Tool 1, check pantry. A pantry availability check, the kind a recipe planner would use before suggesting a dish. isError equals true signals a tool-level error without raising a Python exception. The content list still carries the message. When isError is omitted, it defaults to false. So only the error path sets it explicitly. Tool 2, get recipe card. Think of this as a recipe card tool lookup. Returns the full recipe text as a bundled resource. Use this when the tool needs to return a full document. The complete recipe text, a config file, a report, bundled directly in the response, rather than returning just a reference the client would have to fetch separately. Embedded resource delivers a full resource, URI, MIME type, and data, directly inside the call tool result. The URI identifies the resource. The actual content lives in the resource.text. Tool 3, think of this like a serving chart generator. Returns a PNG image wrapped manually in ImageContent. Images travel as base 64 encoded strings inside ImageContent. Wrapping it in call tool result directly is the lower level approach. You control the encoding yourself. Tool 4, create recipe label. A recipe label generator draws a 200 by 80 PNG with PIN and returns FastMCP's image type. Image is a server-side convenience. FastMCP handles the base 64 encoding and MIME type inference, then converts it to image content on the wire. The difference from tool 3 is only on the server. Image is less code than manually constructing image content. Tool 5, get dish info. Think of this as a dish info lookup. Returns a description in content and application metadata in underscore meta. In this tool, the server tags the result with category, difficulty, and source. The app can use these to filter dishes in the UI, cache results by category, or log where the data came from, none of which the AI model needs to know about. Underscore meta is client only. It never gets fed to the AI model. Use it for UI hints, caching keys, audit trails, anything the application needs, but the model shouldn't see. Tool 6, clear added dishes, a state clearing operation. Removes any dynamically added dishes and signals completion. An empty content list is the correct way to acknowledge successful completion with no data to return. isError stays false. This is the MCP equivalent of returning none. The tool ran, it finished, there's nothing to show. Tool 7, get validated macros. Annotated call tool result of MacroSummary. Think of this as a MacroSummary tool. Returns human readable text in content, machine readable data in structured content, and audit info in underscore meta. Annotated call tool result of MacroSummary is how you combine explicit call tool result control with a type schema. FastMCP reads the pydantic model and generates a full output schema, the only tool in this section that gets one. Next, starting the server. Comment, uncomment to switch. With stdio, run the client only. It manages the server. With streamable HTTP, start the server in one terminal, then client in another. Part 2, the client. Imports. Async IO and JSON are standard libraries. The client is async and dumps the tool's response to JSON. OS and sys resolve the virtual environments part. Client session manages the MCP session. stdio server parameters configures subprocess launch. Types provides text content, image content, and embedded resource for instance checks at call time. stdio underscore client and streamable underscore HTTP underscore client are the two transport options. Next, the setup. Underscore Python here resolves the absolute part of the virtual environment's interpreter. Directory name calls up from the section folder to reach the project root. stdio server parameters describes how to launch the server subprocess, opening the connection. These two lines are the only thing that changes between transports. Everything else stays identical. Client session initialize stays the same irrespective of the transport. Let's first run the client and see it in action ourselves. Everything runs as expected. Let's break it down. 6 tools have output schema null. When a tool returns call tool result directly, FastMCP cannot infer a typed output shape. The content list can hold any mix of item types. Only get underscore validated underscore macros has an output schema because the annotation of MacroSummary gives FastMCP a pydantic model to derive the schema from. Let's walk through to the tools underscore response.json, which was dumped locally after the list tool operation. Let me collapse the input schema first so that this would be easy to consume. The first 6 tools have output schema null. Check pantry has a null schema, so does the other tools. Returning call tool result directly tells FastMCP nothing about the output shape. The envelope could carry text, images, embedded resources, or any mix. With no type to introspect, no schema is generated. Unlike the previous section, where named return types, base model, type data classes, could automatically produce schemas. Here, you've taken manual control of the envelope and given up automatic schema generation. Under the hood, get underscore validated underscore macros is the exception. Output schema present. Attaching MacroSummary via Annotated gives FastMCP a base model to generate the schema from. Here, output schema is present. Attaching MacroSummary via Annotated gives FastMCP a model to generate the schema from. The same shape as any base model from the previous section. The schema comes out entirely from MacroSummary. The call tool result part contributes nothing to it. Now, let's dive into invocation. Our first invocation, check underscore pantry, isError equals true. Session.callTool sends the tool name and arguments to the server. The server runs the function and returns the result in a call tool result envelope. Result has content, list of content items. isError, a boolean, meta from underscore meta and structured content. This is the standard MCP error pattern. Instead of raising a Python exception, the tool neatly returns normally with isError equals true. The error travels inside the envelope like any other result. isError equals true appears in the raw result. This is a first-class protocol field, not an exception. The client checks result.isError before reading content, branching error, and success path. Structured content equals none. No call tool result here sets it explicitly. So it's always none for this tool. Invocation 2. Check underscore pantry. We are invoking the same tool. But this time, where isError equals false. The success case confirms the pattern. IsError false? Content carries the message. Same client code handles both outcomes. Check the flag first, then read the content. Invocation 3. Get recipe card. Embedded resource. The raw result shows the nesting. Content, embedded resource, and text resource contents. The client unwraps two isInstance checks to reach the text. The URI is any URL object, renders as a URL, not a plain string. The actual recipe text lives in resource.text. The URI is just metadata. Structured content equals none. Embedded resource carries its data inline, in content. There's no separate structured layer. Invocation 4. Generate serving chart. ImageContent via CallToolResult. The client detects ImageContent with isInstance of ImageContent type. Same check, regardless of how the server produced it. Content.data is the base 64 string. Content.mime type comes directly from ImageContent on the server. Invocation 5. Create recipe label. The client code is identical to invocation 4. The same isInstance check works for both. The server returned image of PNG type. FastMCP converted it to ImageContent on the wire. Invocation 6. Get dish info. Pay attention to underscore meta at the client layer. The client can use result.meta to drive app behavior. Basically, this is the information that the model does not see. In the raw result, meta appears at the start. The SDK puts underscore meta into result.meta at the client boundary. The underscore is strict. Content carries what the model sees. Result.meta carries what only the application sees, never forwarded to the AI model. Structured content equals none. Underscore meta and structured content are independent fields. Setting one doesn't affect the other. Next, invocation 7. Clear added dishes. Here we are returning an empty call tool result. Here, the content list is empty with isError equals false. This is the acknowledgement pattern. The tool ran successfully. There's nothing to return. Invocation 8. Get validated macros. The raw result shows all three fields populated at once. Meta, content, and structured content has values. Content carries the human readable summary. Structured content carries the typed value. Two representation of the same data for different consumers. Result.meta works here. Same underscore meta result.meta rule as invocation 6. This is the only tool with outputSchema present in list underscore tools. The annotated call tool result of MacroSummary return type is what enables the schema. FastMCP validated structured content against MacroSummary on the server before sending. In closing, call tool result is the envelope. Every tool response travels it. Returning it directly gives explicit control over all its fields. Now, to switch the transport is pretty straightforward. All we have to do is comment out the mcp.run with stdio and uncomment streamable HTTP. That takes care of the server side. On the client side, disable stdio client and enable streamable HTTP underscore client. Next, let's start the streamable HTTP server first. Yes, the server has started successfully. Now let's invoke this server via our client. Yes, all 8 invocations successful. And it is this easy to switch the transport. We covered a lot today. Now, go run it rewatch it, break it, rebuild it. That's how you actually learn. Make it your own. Thank you.